I'm Mate, again with a new joystick. In my last video, I was showing you how to connect this device with the RP24T inside to a PPM channel from the receiver. Now I have made another one, which is this one.
Télémétrie perdue.
And this one inside has an ESP32 underscore S3, the micro one, the sub mini one, and it can be connected either to a SBUS receiver, or it works as well with PPM here. I will show you what it does with the SBUS. The SBUS is much more powerful than PPM, and it provides, even with a small receiver, with a six channels receiver, it will provide you with 16 channels, 8 proportional, 8 switches. So I connect it to the USB, and automatically it will recognize that it is on SBUS. If I launch now the launcher from Phoenix, you see that we get a driver, Microsoft PC joystick, and we can then run Phoenix. And obviously it is recognized by Phoenix from my radio. I can move, launch the plane, and try to pilot it. I'm sure I will crash it during landing because this landscape is very difficult. It is nice but difficult. Second turn. Wow. Landed. Crashed. Okay. Well, this video was not to show you my pilot skills, but I can show you this also. If I go to the configuration panel and I display the peripherals, you can see that here you have now a device whose name is ESP32 S3 underscore dev. I click on it, open the parameters, see the properties, and you see that we have the channels which are operating. Yeah, you see the cross that is moving with the simulator which is reacting in the background. I will not launch it, otherwise I will have to pilot. And for instance, we get here some other channels, just to show you that we get eight proportional channels. But we have also on the other channels of the TX, I have programmed this switch, and this one. And if I move this switch, you see that the button number 2 is lit. This one is button number 3, and this one is button number 1. You can get with this little device, you can get up to 8 channels, 8 buttons on the USB. While on the PPM, you only get on the PPM the number of channels which is provided by the receiver. Here, 6 channels. Okay, in terms of what is inside, I will unplug it. I will remove the cover. And you will see that there is nearly nothing inside. Opening the box. Okay, this is the device I get for very complex for the connection to the FSIA6B. This receiver outputs a signal on 3.3 volts, which is safe for the input characteristics of the I/O pins of this microcontroller. If you want to connect another kind of receiver which is outputting 5 volts, with the logic level at 5 volts, you will need to add 2 resistors on the white wire in order to make a kind of a bridge to divide the voltage and lower it up to 3.3 volts. Well, it is not complex. Okay, that's all I wanted to show you in terms of functionalities. Now we will see how to build it and how to program it. Configuration for the IDE of the ESP32S3 could be somewhat tricky. First thing you have to do is open the file. Then it will open the IDE, and you go to File. So File, Preferences, and you see here Additional Boards Manager URL, and here you open with this button, and you add this one, Expressive on GitHub package for ESP32. You will find the link in the description. You just press OK, you press OK here, and now we have to configure the other things. So the other things, you go in Tools, you have to select the board. So the board, yeah, it's already selected, but the board you have to select is here. You go on the right, and you start by installing the ESP Expressive package. So you have to go to Board Manager. It could be a bit long. Let's see. No, it's working. Now you type here. When I will have the hand, you type here ESP32, and then it's coming this one, the Arduino boards and the Expressive System boards. It is this one that you have to install, the Expressive System 1. So you just click, you select the version which is the latest, and you press Install. Now here it is already installed. Okay, that's all for the board. Once you have installed this, you restart maybe the IDE, I don't remember, but you have to wait a little bit until you get the hand again. It could be long. Okay, Tools, and now you go here, right, you go down and you select ESP32 Arduino. You go on top, and on top you will see the ESP32S3 dev module. You click on this one. It is not finished. You go to Tools, and you have to put several things. So this one, USB mode hardware CDC and JTAG. Okay, not the USB OTG, but hardware CDC and JTAG. You go to Tools again. You have to. You can leave it disabled. USB CDC on boot disabled here. Firmware disabled. DFU on board disabled. This is not important. I just checking. So it's okay. Once you have selected the USB mode hardware CDC and JTAG, it's enough for the configuration of the board. Now you have to configure the libraries. I will not show you it for all libraries, but you go to Sketch. You go to Include Library, and then Manage Libraries on top. You click here. You wait until it's coming. Could be long. Yes, here they are. There, it is checking the already installed libraries and generating the library index. It could be somewhat long also. I will accelerate the video. Okay, yeah, you see that we have finished to upload the libraries, and you just type here SBUS. You wait a little bit. Okay, and you see several libraries which are managing SBUS. The one that you have to install is the not the border flight PWM, but the border flight SBUS. This one by Brian Taylor. So you install the latest version, you press install, yeah, it is already installed. Now you do the same for the PPM. Wait until it comes. Okay, and it is the fanfare la tulipe, this is the French one, ESP32 _PPM, which has a great advantage to use the remote control transceiver peripheral of the ESP32, which is the best with this kind of device. You install and that's all. And you will do the same for the other libraries. I just wanted to show those two, which are the most important. Okay, and then once it is done like that, the only thing you have to do is to plug your ESP and press the this one, the button which is upload, and it should compile and uplink the firmware inside the chip. So that's all for this part. Now let's see how does it work in terms of functionalities. I have here the device which is connected to nothing. I just plug the USB and it will bring up the joystick device. But you see that the LED here is flashing purple, yellow, blue. Purple, yellow, blue. This means that it is scanning what is provided at that level on this pin. Since there is no connection, obviously no protocol is detected. If I plug the PPM receiver, that connection here,
Télémétrie retrouvée.
we have got the telemetry, and we get now a fixed protocol here, which means that it has detected that we are in PPM. If I open the parameters, now it is connected, okay, blue. If I open the parameters of the game controller and the properties, we see that we have the device which is acting and controlled by the motion of the sticks of the TX16S. Now what I can do, it's not the way to use it, but I can do it. It's unplugging directly the PPM, and
Télémétrie perdue.
we have lost the telemetry, and we plug the USB, the SBUS.
Télémétrie retrouvée.
The telemetry is found, and we are now in PPM, in SBUS, and the purple solid light is present. And now, if I take my radio set, we are connected to the device in SBUS, and we see that the axes are moving. I remind you that with the SBUS, we get also the switches, 2, 3, etc. Okay, that's all for the functionalities of the LEDs. Well, let's have a look to the hardware part. It's very simple. So what you have to do if you fly with FlySky FS IA6B device, which is outputting 3.3 volt on its signal pins, SBUS or PPM, as the yellow one, you can directly solder your servo wire this way. The red, which is the plus to the +5, the ground to the ground pad. Then there is a 3.3 volts that you skip, and then you connect the yellow, which is a signal pin, to this 13 pad. That's all for devices which work with a logic level of 3.3 volt. Not all the devices or the RX do this, so what is safe maybe, if you don't know, is to do that. So you will keep the wiring of the plus the ground, and then you will enter your signal from the receiver, supposed to be in 5 volt logic. You will enter it inside a resistor bridge with 2 resistors in serial to the 2 kilo ohm and 5.6 kilo ohm. This part being connected to the ground, and the middle point being connected to the pad number 13, GPIO 13. So this is very safe. Whatever your receiver, if it is outputting 5 or 3.3 volt, it will work, and it will never burn or fry your pin, your input here. So I consider it's the best option. Okay, that's all for this video. If you like it, well, say it, and don't hesitate to click on the like button, or even you can follow this channel. This will be very helpful. Thanks a lot. Bye bye.